All right, here's a level 5 type question. What is the measure of the interior angle? And you have one interior angle. And notice this is a regular polygon. Okay, this will not work for an irregular polygon. Okay, unless they told you all the other angles, and then we could calculate this one. All right, we know that the sum of the interior angles in a regular polygon is going to be like 2 less than the number of sides times 180. Okay, let's go and have a look at why. Alright, so the measure of one interior angle in a regular polygon. So what we're saying is if we start off at one vertex, let's say we start off right here, okay, we draw a line to every other vertex, like to here, to here, to there, to there, to there, to there, to there, to there, and then to the last one. We end up with, notice how many, like we had 10 sides, notice we end up with 1, 2, 3, 4, 5, 6, 7, 8 triangles. You always end up with 2 less triangles than sides if you do it this way, if you're making triangles that way. Okay, so that gives us a nice formula that the sum of the interior angles is going to be 2 less than the number of sides times 180, because you know that the sum of the angles in any triangle is 180 degrees, right? So in this case, we're going to have 8 times 180 is going to be the sum of the interior angles. All right, and then to figure out like what one of these angles is, we're just going to divide by the number of angles, right? The number of angles happens to be the same as the number of sides by n. Okay, so n minus 2 times 180 divided by n would be one interior angle in a regular polygon. All right, so for this example, I'm going to say, okay, we have 10 sides, take away 2, 8 triangles, 8 times 180, all right, is 1,440. Okay, degrees. So that's the sum of the interiors, right? They're like all of these angles together. Okay, all 10 of these angles together. So one of them is just divide by 10. Okay, divide by the number of angles you have. Okay, it's different for the different polygons. So in this case, we have a 10-sided figure, so I divide by 10. So that's going to be 144 degrees. All right, so let's try that out. So 144 degrees. There's my degree symbol right there, and enter.
Yay.
Yay. All right, this is a hexagon. So there's going to be 4 triangles. So 4 times 180 is going to be 720 degrees. Okay. So 720 degrees divided by 6 angles, right? So the sum of all the interior angles is 720 degrees. Divide that by 6 is each one of these angles is going to be 120 degrees. Okay, 1, 2, 0 degrees. Okay, this is pretty simple. This is a equilateral triangle. We know that the sum of these angles in any triangle is 180, and they're all the same angle, so it's going to be 180 divided by 3 is 60 degrees. So 60 degrees. Okay, here's a heptagon. All right, so we're going to have 5 triangles, right? If we start at this vertex and draw a line to that vertex, no triangle, to that one, we get a triangle, 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 no triangle. So we have 2 less triangles than the number of sides. So we're going to end up with 5 triangles, right? All right, so 5 times 180 is going to be 900 degrees. All right, so 900 divided by 7. Okay, handy dandy calculator time. So 900 degrees divided by 7 is 128.57142. I'm just going to copy that and paste it in here and round it, let's say, to 4 or 5 decimal places. So the 2 will tell the 4 to stay at 4, and I'm going to put a degree symbol there and enter. All right, well, that's clearly 90 degrees. 90 degrees is a square. Square means 90 degrees right there. So enter. Okay. All right, and that's it. Have a good day.